So why don't you tell me who you are and what you do at Dell?
My name's Kevin Kettler. I'm CTO at Dell.
And we're going to talk about virtualization. Is that what we're focusing on?
Yeah, I wanted to take a few minutes and walk people through virtualization, kind of a little bit of tutorial on virtualization, and then walk through what is changing, what's new about virtualization today, and why Dell is very much emphasizing virtualization as we move forward. So what I thought I'd do first is just kind of walk you through virtualization in its basic sense. So if we think about virtualization, we oftentimes talk about you've got a hardware layer which would represent a single physical machine that we might be dealing with. Normally there's two different types of virtualization we'll talk through, but let me just start off with a simple one of today we think about a piece of hardware, a machine. Normally on that machine is an operating system, a number of different applications that might sit on top of this operating system. And typically these applications is the operating system is single operating system to single machine. The applications, then there's multiple applications that would run on top of this operating system. There are companies that have historically come out with products that help virtualize, and they virtualize actually off of this platform where they'll create a virtual machine manager effectively that then allows you to layer on another potential operating system and applications up here. So effectively what you have is in this model or topology you have hardware, operating system, shared apps within a virtual machine which effectively sits almost as an application here, an OS that sits on top of applications. As you can see, there's a lot of layers that you flow through, and the purpose of this piece of software is to effectively create the perception by this operating system that this operating system actually owns this hardware solely down below. There's another model with virtualization that I wanted to talk about, which is where you actually have a single machine. This is your hardware down below. And rather than having an OS and then your machine manager sitting on top of here, OS and applications, you actually have a small, lightweight piece of software. You'll often hear the term Hypervisor, or another term for this is VMM, Virtual Machine Manager, which sits directly on this hardware. And this allows you to go ahead then and actually layer on operating systems just directly onto this hypervisor that then controls down through the hardware. So it effectively eliminates some of the indirection that we go through here in the different layers and allows a much tighter control and management of operating systems down to the hardware. So this is a direction where the industry is, you're seeing a lot more investment and work around this in the industry, is creating these hypervisors and virtual machine managers to allow a wide variety of operating systems. It doesn't even need to be common operating systems coexisting within applications that would sit up on top of these OSs. And in some cases, we talk about the application to OS binding almost being a one-to-one thing, in which case we almost say this can virtual machine, each one of these virtual machines would effectively appear as almost an appliance. You're plugging in a application-specific OS and application that's going to sit on top of this. So as we look at this architecture and this type of activity, virtualization, has been around for over 30 years. So this is not anything mind-boggling or earth-shattering that has come about recently. The things that are changing, though, are a lot of the dynamics around the industry and what's being delivered, and that's the important part. So let's first talk about hardware. One of the areas in hardware we're moving to, like dual-core, multi-core processing elements. If you think about that a little bit, what that means is you'll have a processor that effectively is two processors within a single device on this box. And what I like to think about is what happens if you start to take and really bind a given processor to a given virtual machine. There's a natural affinity to be able to create the perception of dedicated hardware back here. And the reality is you might actually be dedicating hardware down in this single machine by virtue of these multi-cored technologies. And what's happening is this is not just happening on the processor front, but what you'll see over the next few years is it's actually happening through the I/O front. So things like comms is a great area, the communications area, network controllers. Things are changing around how memory is handled and other I/O activities. In addition to, one of the tougher ones is around graphics and dealing with graphics virtualization. But the good thing here is hardware is now a single box, where we thought of a single box with single processing elements is now a single box with a multitude of processing elements that can help better align to virtual machines. So that's the first thing. The second thing is whenever you begin to look at this, there are other things that are happening in, for example, the processor front. So you've got folks like AMD and Intel that are all innovating by adding hooks into the processor. Intel uses the term VT, AMD uses Pacifica as the term to describe the hooks and the things that they're putting into the processor to help accelerate and facilitate this notion of a virtualized environment. So that's the second thing that's happening. And then the third thing that is happening is really a statement around, this is a hardware enablement statement, but you've also got this cost factor. So if you went back and looked at something like this in a traditional system today, you would have bought your hardware, you'd bought a license for an operating system, you would have bought a virtualization piece of software for a cost, and another operating system license, and you can see that the additive cost in through here can get pretty expensive. Relatively, not overly expensive relative to the overall setup. But when you move over to this environment and you look at this really lightweight piece of software in here, that's the Hypervisor, this we expect to really not even be a significant dollar cost if we go ahead and make this a standard part of even, let's say, clients as we drive it into clients. The cost factor associated with driving this as a ubiquitous part of just the underlying platform is that everybody would have a hypervisor. In addition to the fact that there's folks that are working on this in the open source community that's going to further promote the delivery of this type of software at a near free level, we think is a big game changer as well. When you roll all this stuff together, you end up with a cost factor here that will shift significantly. We still have two OSs here, so you might say you still need licensing around this, but one of the things that we're looking for the industry to shift their view around is how do you handle licensing in this environment going forward? Because I think that's a critical factor, and that's something we're working with a lot of independent software vendors as well as operating system vendors on how do you license in this environment, because you've got unique images that you might be replicating multiple times over on these things. So there's a lot of good stuff going on here, a lot of exciting news around virtualization. We are spending a lot of time with our development teams as well as within our labs to really drive the concept of virtualization and the customer benefits around it. What I've described is kind of why it's emerging. There's a whole other set of benefits that walk through what you can do with it in the enterprise class customers, such as consolidation of servers, or on the client side in just using this as a way to manage unique appliances, as I'll describe them, some of those which might provide better security or reuse or less contamination between these virtual machines. For example, if you might have a home VM alongside of a business VM, in which case you're able to work on your home data and information and not potentially corrupt or contaminate anything you might be doing in your business VM, as examples. Other items here could be introduction of a VM around system management or diagnostic work, which doesn't even need to have a full purpose OS sitting on it. It can So if your OS isn't even running, you could potentially go in and use this as a means to diagnose issues with the hardware. So again, we're very optimistic about where virtualization is going, and we think this is a technology to continue to evolve and see it move into the mainstream.
Very good. Well, I appreciate you taking the time.
You're welcome.